Harshit, with this note, would like to extend my warmest greeting to Chief Gesture and everyone attending this precious online training session. First of all, without wasting much time, I would like to invest our first speaker, Mr. Nikhil Shah, to speak on the topic, the foundation of artificial intelligence. Knowing about Mr. Nikhil Shah, he is a seasoned executive with more than 25 years of experience, specializes in building software product services, corporate and academic consulting training. He is a director of Silence System, and his focus areas includes data science, big data, AI, LM blockchain, data visualization, 5G mobility, blockchain, and digitization. He is also an APAC ambassador of Broadband Forum, a global standard body. He has been engaged with the designing delivery talks, custom workshops to various clients, ranging from corporates to leading academic organizations. Mr. Shah is a frequent speaker at various industry conferences worldwide. As a passionate technologist and trainer, his approach towards training ranges from building a technology business foundation, and he has been awarded Broadband Forum Leadership Award by Board of Directors, Hong Kong, MFA Forum Award, and GM's Award. He has great volunteer experience and leadership too. I welcome you, sir.
Thank you.
And the other speaker is Mr. Kishan, who is to talk on the topic, a role of cloud-based IoT technology in precision horticulture. Mr. Kishan, an IoT domain expert and corporate academic trainer, as a consultant with Silence System, he is a lead corporate and academic training related to IoT. He helped in designing and delivering custom workshop as per client's needs, in building a business cases and ROI model for products and services in market research, comparative study of solutions for similar nature. He has got involved in various student levels in industry grade project implementation. Apart from this, he is a lead instructor at Pearl Industry, Delhi. He did task manage to workshop across the different campuses like Delhi West, Delhi South, Jaipur, Mumbai, and also in Bangalore. Teaching models are interactive tools and IPD. Train staff and students for safety machine training, focused on developing innovative programs, developed ideas, and preparing students for research and innovation. He is creating a safe and efficient environment for students to engage, also presenting workshops on various platforms for collaboration and supporting faculty and students in development of their ideas. However, planning workshop layout and experimenting on AR, VR. Furthermore, I also instruct a Fab Lab set Ahmedabad. He is also managing the workshop and project implementation, facilitating the workshop. I also welcome Mr. Kishan to this meeting.
Thank you so much.
Okay. Now let us start the first speak with Mr. Nikhil Shah, sir, and Mr. Kishan.
Harshit, dear participants, we are going to have first session, which is on role of cloud-based IoT in precision horticulture, and that will be taken by both of the speakers, Mr. Nikhil and Mr. Kishan. And I will invite first of all Mr. Nikhil to proceed with his session. Over to you, Mr. Nikhil.
Thank you so much for inviting myself and Kishan. We are pretty excited to this morning session with dignitaries, students, faculties of Agriculture University. Thanks, Harshit, for a warm introduction. So allow me to share the screen. And our discussion this morning is about IoT and cloud, both how they are relevant into precision horticulture. So that's our topic, and the way we are going to cover in next 90 minutes. We wanted first, let's define some of the terminology about IoT and cloud, as I assume some of you perhaps might be new to these domains. So we'll just quickly establish the industry trends and motivation for leveraging IoT and cloud and how they are relevant. And then we will be defining the precision agriculture in very clear definition. And then we have number of examples and case studies about use of IoT and in the context of cloud in the agriculture. And we'll be looking at some of the constraints that we should be aware about in implementing IoT. Even though concepts is excellent, there are some constraints and limitations that we should be mindful about. So that's going to be our agenda. This is just my quick introduction. So let's look at some of the macro trends in the context of IoT and cloud. So first of all, if we look at the global phenomenon in the world, probably 97% of the water is unusable, either with the ocean or either in the in the different formats. So probably 3 to 5% is the water which is consumable, and even out of that, the larger water body is used by agriculture sector, which is one of the largest consumer. The agriculture sector is very dependent and very vulnerable for changes with the climate and water conditions, right? And that is what makes farmer dependency and livestock dependency in a very difficult way, depends upon the situation. So any changes into climate and water conditions is going to have a direct relationship with the crop yield. And that is also very critical to achieve and maintain the global food supply, food securities. One of the very famous book about the world is flat, which is written by one of the leading Fiederman, one of the leading journalists of New York Times. It's very good book. I would highly recommend. If you just wanted to look at the whole overall world trends, one of the opening chapter, it mentioned that if the future world war would happen, it would happen for the food and water, right? And so with very legitimate reasons been given. So in general, food and water is rising, the demand is rising, consumption pattern is changing, global pollution and further development is going to cause more and more demand on agriculture sector. So any technology innovations and solutions which would address this problem would be highly welcome. Now, if I look at some from purely IT perspective and from purely technology perspective, if I have to put the finger on 3 main trends in next decade, what would be those? So one is there's going to be mobile internet. See, in the world, we are about 700 crore humans, so 7 billion people. But by end of this decade, there's going to be 30 billion devices are going to be connected on wireless network. And those devices is what we are talking about, IoT. I'll cover in the next slide. IoT stands for Internet of Things, right? Another big trends, it's cloud. Just if I go back 5 years before, back in 2016, the public IT cloud spend, when I say cloud means we're talking about Google Cloud or Amazon Web Services or Microsoft Azure, or you're hosting your websites, or if you have a bank account in HDFC Bank, where your all FDs and bank balance details has been stored, everything is on the cloud, which is, think about is a machine or computer away from your home, right? Where all the data is stored and securely available to all the people. So back 5 years back, almost $100 billion was already crossed in cloud spending. So that is another big area. And the third, and one of the important area, which is total consumption, was 60% of total traffic, total internet traffic, which is generated, which includes entire Wikipedia or all the files, all images that we share on WhatsApp, on Facebook, or all the emails going across the world. This was back in 2015, that 60% of the all internet broadband traffic was video. And that number is staggering to 80% now. So my point is, video and content is going to be instrumental part of our day-to-day life in terms of cloud storage. Now, just to give you perspective, just to establish that we are all on the same page. If you look at back in 2000, right, when the PC revolution, when the PC revolution started, back in 2000, when PC was a big deal, the desktop machines and whatnot. So about 100 million connections, they were connected to internet. They were connected through some kind of networking mechanism. If you fast forward 10 years, from 2000 to 2010, that number, which is the devices which are connected to the internet, has grown up 20 times. So from 100 million to 2 billion. So 2 billion connection, and largely it was contributed to smartphones, right? The one that we are all using for last decade. The emergence of mobile phone, now that number itself is almost more than 5.5 billion devices are connected, or mobile stuff are connected to the internet. So back in 2010, it was 2 billion connections. And now, if you fast forward another 10 years, by 2030, or I would say another 20 years, you will see that growth is still multiplying 15 times. And this time, it's not just mobile phone. It is going to be the different sensors. So these are some of the main sectors which are contributing to such a massive growth. And this is what we are referring to as IoT, Internet of Things. Earlier, it used to be known as a M2M, machine-to-machine communication, right? So this is what is going to bring major tsunami in terms of data being generated. So let's take some of the simple examples, right? That these days you are having your health watch or MI5 or Apple Watch that measures a lot of sensors data of your from your body, and it can communicate to the doctors, the public safety, right? In Ahmedabad or in major cities in India now, the government is implementing the cameras where if you are violating the traffic rules, you are getting the challan or tickets, the traffic violation fine at home with the proof. Now that data which has been captured is all communicated through internet to the central governance body. Industrial IoT, home automation, right? That you can control your home air conditions and lighting and media and everything from anywhere. You can be anywhere in the world. Utility companies, transport, drones, the tolls, digital signage, right? You see that on the many places on the road. You see the digital signage that keep on changing, depends upon what campaign they want to run. So I can go on and on, but these are each of these devices, including the cow in agriculture, right, or in livestock, all going to be tracked, just like we can be tracked with a mobile phone. So all of these devices are bringing traffic on the internet, and it brings slew of new applications that would be possible because of this. Let me take another example just to initiate the stage. Let's say I'm the fan of organic food. I am, I don't like pesticide and I don't like the artificial heavy use of fertilizers. And I go to a shopkeeper and who is selling the fruits or apples with the label of organic, right? Now, putting the label, it will cost probably 25 paisa or 10 paisa to put up that tiny sticker, which can be labeled as organic. In some countries in the world, it is highly controlled. That means government have a very tight control about who can sell it as organic and who cannot. In some parts of India, that probably may not be the case. So how would we use technology? And that's where today is not the topic of discussion of many other technology. Our focus is cloud and IoT. But in very similar space, there is a technology called blockchain. I'm sure everybody in the audience knows about Bitcoin. The one Bitcoin is costing about 30 lakhs rupees. We are not here to talk about cryptocurrency. but the technology which is supporting the Bitcoin, which is called blockchain. So blockchain technology has a huge promise of transparency and traceability. So here I can scan a simple QR code, which can be labeled on the carton of Apple or on every Apple. And I can scan that QR code, and that gives me the complete supply chain traceability, that these apples were being picked up in this particular farm in Kashmir, Valley of Kashmir. Then it been received in Jammu. From there it went to Jaipur. From Jaipur it has came by train to Ahmedabad, and from here to retail shop. So if you would have complete traceability and you can go and verify, and since the data is on the blockchain, it cannot be altered, right? So there are many such applications which is going to bring a massive revolution and new business models in the agriculture sector. Let me take another example just to set the stage of our conversation. The image that you see on the screen, it is taken from NASA satellite. This is about north part of India. That you see all the red dots. Each red dot represents the fire. We know that in Punjab region, people, farmers particularly, set fire to their fields to clear all the weeds and unnecessary plantation. And this is going on for decades, right? This practice. This is how they clean up the pets and also unnecessary crop, and they basically get the good ash, which can be used as a fertilizer, a natural fertilizer. But the byproduct of this, there is a massive amount of smoke. And we all know that in Delhi region, part of the pollution is caused by this massive burning happening across the northern region. So this health, heart disease, lung disease is getting severe, and people get into some chronic health conditions. In fact, the gas like carbon monoxide, it is invisible, and it does not smell either. But if there is a higher concentration of carbon monoxide, it can make people faint and even can be very deadly. So ideally, we should change this practice in India, but even till that point, for a human safety point of view, very simple device like gas sensors. There are many gas sensors available at relatively very cheap cost, 100 rupees, 200 rupees a sensor, that you can combine with a small dangerous gas monitoring system, that nearby to your home or nearby to farm, when you detect some very toxic gas like carbon monoxide, then you can immediately move away from it. And that can be many times people just not aware about it, and they are inhaling these dangerous gases and cause some major problem. So for overall health conditions of farmer and their families and livestock, simple solutions with IoT can be instrumentally beneficial, right? Now let's look at some of the reasons why crop failure, or why there is a low yield of the crop, right? So these are some of the very obvious. Probably we don't have to tell you guys. Agriculture university knows this stuff by heart, like soil fertility and poor practices being followed, climate factors, obviously a big part of it, and lack of proper agriculture inputs and data points, right? One of the big thing that we can learn from the data is the predictability, right? If I have a historic data of last 100 years of temperature, rain, I can establish the correlation between temperature and rain data with the weather, for example, or for crop predictions. So if you understand the reasons for crop failure and you can back it up with the real-time data, you can take a lot of corrective actions that improves your yield of the crop. Yield means whatever your investment you've done, you're getting better ROI. In general, what is important to understand is we have to look at agriculture or horticulture as a transformation opportunity. To give you one parallel example, our finance minister Nirmala Sitharaman during the COVID time, she mentioned that millennium Uberization. That means young people, in their 20s, 25 years old, they prefer to use Olas and Uber rather than driving their own vehicles and sitting in the traffic for hours and 2 hours in a cities like Bombay, Delhi, uh, and Chennai and stuff like that. So Uber culture is becoming a very norm and being accepted as a normal practice. Now, what does it mean? It means less, it is going to impact the auto sector. And that's why Nirmala Sitharaman has mentioned that the reason why auto sector was not doing well earlier few years because of the Uber culture. The taxi and rickshaw business is going to be impact. Insurance business is going to be majorly impact. The banking and loan, because some of the large private sector banks almost giving 2,000 crores rupees of auto loan per year in a certain part of India. So that business is going to impact. If you have more and more Uber cars, that means you don't need to have your own vehicles to park. It's going to impact the parking space in the large cities, right? You don't need a massive parking facilities. Like cities like New York, for example, they charge $35 per hour for parking in certain parts of Manhattan. And with Uber culture, that's going to change. My point is just one innovation with mobile application. After all, what is Uber or what is Ola? It's a mobile application, right? They don't own any vehicle, literally. Just mobile application can make such a massive change into business. Similarly, if we adopt IoTs and cloud, I think it has a huge potential to bring major transformation in horticulture sector. To give you another example, Hilton, which is the largest hotel chain in the world, it took them almost 93 years, 100 years to reach to 6.1 lakhs or 6 lakhs plus rooms in 88 countries. And Airbnb, it is again the website and mobile application. It came in and it took them just 4 years to surpass what Hilton took 100 years. So they reached 6.5 lakhs rooms across the world in 192 countries, right? As they are almost doing 1.5 lakhs booking per night. Airbnb is basically, if you are owning the home and if you have surplus room, you can give that room for a rent, right? Now, this model is called sharing economy, right? Or basically it's transforming from sharing economy to on-demand economy. So this kind of business models are basically live data, live feed, live information to make a live decision. This is a kind of future, and this is where IoT and cloud would be helpful. Now, let's quickly look at what I just talked about, that the human has evolved as image very clearly expressed. And now we are doing a lot of stuff sitting with the computers and your mobile phones to make your day-to-day decisions. The future is going to be hybrid workforce. Means, see, we all know that robots in actual physical form or robot in form of software processes are going to compete with humans. In fact, many of the jobs, whether we like it or not, are going to be taken over by machines or by robots. But they are controlled, they are being designed by humans. So the future workforce, whether it's agriculture sector, whether it's white collar jobs or is office environment, is going to be hybrid workforce where human and machines are going to work hand in hand. In fact, many of the jobs that humans are doing on a repetitive basis, they are definitely going to be taken over by these machines. So we need to be mindful about it. Now, if you look at some of this IoT application, again, I'm putting some data 5 years old, and then I want to show you the data of last year. These are some of the top applications like wearable electronic, like health watch, the smart city, smart homes, industrial. These are the different overall popular applications. Now look at smart farming from the agriculture point of view. It has not been that popular compared to other stuff. Even if you look at in 2020, agriculture has significantly improved, right? From less than 1% to 4%, but in the overall scheme of things, it's still low. part of the reason could be that lack of technology awareness and lack of perhaps unknown or fear of uncertainty. Basically, there is lack of knowledge and lack of technology knowledge, and that probably the reason why, even though there are significant benefit of IoT and cloud, agriculture sector is still not or have not yet adapted to the full scale. Now, let's next few minutes I'll just spend on IoT, and then I'll hand it over to Kishan. See, whenever we term IoT means the billions of smart devices, connected people, systems, different sensors like temperature sensors or water sensors or soil sensors, they all are connected together to share the data over the internet to make some informed decision, right? So this is going to be a major transformation. And as I said, almost 25 billion to 30 billion devices are going to be there on internet, which is sensors or IoT sensors data. This probably would give you a very quick snapshot starting from 1990s to 2020. Evolution of this PC, laptops, windmills and plants, traffic lights, automatic toothbrush, so and so forth, like smart electrical things and smart monitors. So this is been evolving, and it's going to continue to evolve in next 10 years. But in essentially, how does IoT system looks like? In what we typically see, like driverless car or rain sensors and all of that, these are the smart things, or you can call it smart devices or machines, or Internet of Things, right? So these are those end devices. They are connected through some kind of gateways, and then using some middleware where we get the data, we clean up the data, and then we analyze the data. We do, there are a number of various applications like mobile applications, which would take this data and then help you to make informed decision. So essentially, any typical IoT deployment, essentially, it has 4 more components, right? Smart devices, network, middleware, which basically take the data and transform into decisions, and then visualization applications through which you can see these IoT blocks. This is probably perhaps same diagram, but top-down format, where these different devices are connected through gateways, and each gateways are connected through internet. So these sensor devices can talk to each other, and they can talk to the humans, and then we can make the informed decisions. So this is just a quick summary of number of applications that IoT can offer us, like smart homes, smart cities, self-driven or driverless cars, IoT retail shops, farming, wearable electronics like health watch. These days, a lot of these devices are coming up that you can, if you have older people in your home, you can just put some belt, not very lightweight belt on their chest, and it monitors the heart, it monitors the lungs, it monitors oxygen level. So even every half hour, the vital body parameters are sent to their son or daughters, or even to doctors. So if there is some heart disease conditions are developing, the IoT device would be able to alarm that ahead of the time. Similarly, smart grids, telehealth. When I say telehealth, think about it that India 65% population still live in the rural places. And many times we know that they cannot come to cities for emergency treatment in time. And then many times it's a very fatal and people lose the life. With the innovations with IoT and 5G technology, the remote surgery would be possible because the delay in the network is significantly lower in 5G technology compared to 4G, almost 90% improvement. So remote surgery means doctor is sitting in the Bombay or Delhi or Ahmedabad and is guiding the doctor in some rural place in Amreli, and then able to save the patient's life. So many such industrial grade automation as well as remote surgery kind of applications are possible because of 5G and IoT. I'll give you one, obviously traffic management and water waste management is a big area. Just to give you point and case example, one of the solution that our team and Kishan, we all developed for government of Gujarat. So this is a simple proof of concept that we developed. Basically, it was deployed in Gandhinagar in some government buildings where they wanted to monitor the electricity, basically current and voltage and temperature into couple of government buildings, because many times it happens that a lot of electricity was wasted. Even after 5 p.m. or 6 p.m. in the evening, air conditions were turned on, they never been turned off. And in the case of any terrorist or some severe or unpredictable situation, they wanted that power supply parameters are informed to the nearest electrician and without using Wi-Fi. So we have developed the RFID, radio frequency based transmission system, which does not use any mobile network or Wi-Fi network, and still able to communicate and measure any electricity or voltage failure. So again, this is the classic solutions for smart monitoring or smart cities, smart government buildings, and it can significantly save the cost, and it can be very useful in the emergency situation. So again, this is achieved by using different sensors and software piece of a software code. So this is how the IoT works. Now another data point about cloud. We are talking about cloud and big data. So big data means what? There is all kind of data are going to be generated, which could be your emails, which could be WhatsApp messages, which could be Instagram post, which could be Facebook post. There are almost 3 billion posts happening, or 3 billion people are connected to Facebook. So there is so much of data is coming on the network, including so many IoT devices are going to come, right? So everything has to be managed, and that is the concept called big data on the cloud. And basically in the cloud computing, see, you must have heard these terms very often, that cloud computing in IT terms, it means the network, internet, the servers, where it hosts the data, storage, which is hard drives, which holds years and years of past historical data, various applications and services. So this is all encompassed into cloud computing. And these three terms we should be keep in mind, which we'll be referring later on also: software as a service, infrastructure as a service, and platform as a service, right? So if I wanted to deploy this IoT based smart agriculture system, I can buy own servers, I can buy own hardware and deploy in my own farm, or I can just rent the space on a public cloud such as AWS or Google Cloud Platform or Microsoft. There are a number of public cloud providers where I can outsource a lot of this functionality, and I can only focus on my data, right? So these are the different cloud deployment models, which is probably, we don't need to go into a lot of details at this point, but the cloud is accepted. We don't have to worry about the cloud. Cloud is highly secure. Lot of financial information, all our Gmails, everything is securely served on a Google, on the different clouds. So that's the future where we'll going to leverage a lot of cloud infrastructure to deploy some very smart horticulture, precision horticulture kind of systems. All right. So with that, let me invite my colleague Kishan to take over, and we'll go through some case studies with IoTs and cloud in the horticulture environment, starting with precision. What do we really mean by precision horticulture?
Right. Thank you.
All right.
Kishan,
you can share your screen.
Yeah, let me just share my screen. Yeah, I'm trusting the technology, so my screen is visible to you because we are here to talk about the technology. right? So let's say we heard about this precision agriculture. What is it, right? So uh, let's say it's an improving technology. It's a use of technology of improving the crops, right? Or the tools that we have, or managing the way of how we farm, right? How we do a farming, right? So that's a precision agriculture. And we as a human has a tendency to get the maximum out of what we have, right? So why don't we use the technology to take the maximum out of it, right? So into a simple words, what the precision agriculture means for me is it's that anything makes the whole process of farming, right, accurate and in a controlled manner, like when it like whether it comes to the livestock monitoring or growing the crops, right? Suppose, let's say we have a very limited resources now, right? So in terms of if I talk about the world population is growing as a faster, okay, so that's how the food consumption and the water consumption is also growing, right? And if you see on the other side, the areas of farm field that we have is also going it's also going it's also decreasing day by day, right? So now there is a concept of vertical farmings are also booming, right? So it's all about how to get the maximum out of what we have, right? So let me tell you a story, okay, about the Madan Bhai. Like let's say he's a very old man, or he's into 90s, right? Where the population of the world is also very limited, and the resources that they have is also like good resources, right? And then they have a kind of superpowers. So I'm not from a farming background, but I born and brought up in Charotar region in Kheda. So I have a lot of friends who are the farmers. Okay, but if I see the trend, right? In past, a lot of people are just checking it out, and they take the decisions, right? They have unlimited access to the resources. But now, if you see, now the Madan Bhai, the farmer is using the technology, okay, and using the smartphone, using tractors to get like to decrease the efforts that he's placing into placing in farming, okay. And you guys all know probably that the farming is a very labored business. You need a large workforce for that, right? And that's how the money goes away, okay. So here they are using the smartphones also. Nowadays it started like in every corner of India or every corner of world, the smartphones are available. But we have to think about it. Are we really a smart, right? So let's say what will be the future? If you see the future, people are saying that the robots will take place the human. But I don't think so, right? If somehow we can leverage and we can like control that technology, right, and make the use of it, right, so we can become a controller of that entire system, right, and we can become a part of that system, right. So there are many constraints to that, okay, so for introducing such kind of technologies. But somehow if like every good innovation is coming up with the problem, right? That if there is a problem, then only you can think about the solutions, right? So it's good to have a problem. Okay. So if we talk about the IoT and cloud in agriculture, okay, there are few of the sectors that we can work upon. Okay, let's say what is IoT? Mr. Nikhil talked about it. So like every time if you wake up in the morning, right? Many of the people have a smartwatch, right? So they can just check what is my calorie count, what is how much sleep that I got, whether I want to drink of water or not, right? So that's for a personal use. Okay, we are spending money to get the health benefits, right, of it. Or we have Alexa and Siri, we or a Google Home, we can just say, Alexa, play a song, right? So it can play a song, or it can calculate the complex problem, right? So, so if I talk about in context of agriculture in IoT, there are few sectors that that you can think about and work about, or IoT can help into a developing or data driven developing into that sector. Or one more thing that I want to mention over here. So if you see the next trend, okay, on next trend, let's say the data is also money nowadays, right? So suppose if you see any of the marketing company, right, what they are paying for it, they are paying for a data, right? If you search something on Amazon and you are getting the same advertisement on a Instagram or a Facebook, right? How this is happening, right? It's all based or backing of the data, right? So if I talk about in the context of IoT in agriculture, there are few sectors which it is divided, right? You can monitor the crop, you can monitor the fields. There is drones, there is sensors and all. Okay, let me just go and talk about it. Suppose if you see the robotics, how we can use the robotics into agriculture, right? Robotics can be used for weeding the, like providing the, what do you call, like what do you call, yeah, like दवाई डालने के लिए यूज हो सकता है. Then machine navigation, like automatically you can control the tractor. Suppose somebody is not able to drive a tractor, right? They can use the machine navigation system and use it for like farming, right? Harvesting robots, so taking out the end product from the trees. They can use the robot. One story that I was watching the YouTube. One story that I got in Africa. Avocado is very booming business, and it's a costly as well. So there, the stealing of avocado, okay, is very frequent, right? People come into the night and they steal the avocados, right? So they had implemented cameras and the system, or nowadays they are implementing the robotics, right? So robot can quickly harvest the avocado, right? And also you can use it for material handling, right? After like if you see any process, any manufacturing technology or anything, it has a two parts of it, right? Either you can handle the material or the deployment of it. Okay, so it also can be used into a precision farming, right? And sometimes ago, few minutes ago, we just talked about what is precision farming. It's all about a data driven farming, right? So like you can place a number of sensors into your farm, and then you can then you can start predicting if suppose into a summer, right? I might be needing a water, right? So that's how the precision farming can also be used as in agriculture. Then there is application of agricultural drones, right, where you can use it for getting the imaginary data from the top, and then you can take the decision whether I should apply the water or how much amount of fertilizer that need to be go into my farm, right? So enhance the farming practices. Then livestock monitoring. This is very important, right? Every farmer nowadays, if you see, they have cows and the buffaloes. So like sometimes it happens. You have to manage. You have to check the diseases, right? Whether you have to check the quality of milk, the diseases into a stock, or where they are going, right? So how monitorly, okay, without going outside, how you can check it, okay? And there is a smart greenhouse. I think for a greenhouse, you guys know better than me, okay? So like greenhouse is something which is very controlled temperature, and then you can grow the crop over there with a very controlled environment, right? So monitoring the climate condition, this is very important, right? If you see the majority of the crop failure, about 53% of the crop failure, it's because of the bad climate condition, which is like flood or no rain into that area, okay, or the given the time, the fertility of the soil is also decreasing, okay. So how you can continuously monitor it and take the precautions, okay, for not failing the crop. Remote sensing, right? This is very important. I think you must be heard about the sensors and all, right? What is sensor? Like anything which is a physical phenomena, right? Any physical phenomena that you can sense, right? Suppose there is a moisture into the soil, the pH level of the water, the temperature of the crop. These are some example of farming. And if you see into very general, like if you want to measure the distance from point A to point B, then if you check into the healthcare, right, the heartbeat, right, the neurology map, these are all the sensing, right? And those remote sensing, you can create a remote sensor and use it in your field to get the condition of the soil quality or crop assessment, how much percentage of the nutritions that you are growing is there. And if you compare the the best product, the best product will get the best price into the market, right? Then there is also a concept called computer imagining, okay, from where you can take the image from the top, okay, for controlling the quality, sorting and grading, right, and checking the dryness of the soil, okay, like if you allow the water to go into the field, but you have to check it into the loop that whether it's going everywhere, every corner of that farm or not. Okay, so how you can check it? You can just use the computer imaging. Okay, so let me talk about a very simple solution. We talked about a lot of technology, a lot of terminology, but when it comes to the implementation, right, that's very important. How we can implement that? Okay, let's say for an example, you had been tasked to measure moisture available into the soil, right? So if say if I like if I am into the 90s, okay, or I will be the mother bride, right? I just told you the story about it, right? What I'll do, I'll just check the soil from my hand, okay. But what type of data that it will give me, right? Because I don't have that superpower, how much amount of water will be going inside it or not, right? Even if you see the human tendency, right, after the introduction of the smartphone, you can't remember this phone numbers, right? Even when I was at home, right, my father used to tell me we used to remember the lot and lot of phone numbers. But now because of this smartphone, right, the facilities of storing the data, right, you can't remember you can't remember that, right? So here also, right, we are somewhere we are losing out of those senses, right, because of the dependency on the technology. I'm not saying it's technology is bad, or I'm not saying technology is bad, okay, but how we can use it for betterment of ourselves, right? So you just check the soil, okay, and like then after checking it, how much you can derive, okay? Can anybody tell me how much amount of water is required, okay? So sometimes it happens either you overpower the water, or you apply the less water, right? So so now if you use the technology, right, the sensor which can detect the soil moisture and then give you the graph, how much water is available, and then you can ask somebody to go into your field, right, and apply the water over there, okay. This is just only that, okay. Why we can't be why we can't use the technology, right, from the beginning, like from checking of the soil to switch on the pump. Okay, so we should not be we don't have to be dependent upon someone to apply the water, right? So checking the soil. So here we are completing the entire loop. We just don't want to get the data. Okay, we are interested into taking the precautionary actions wherever it requires. It is very simple solution. You probably you had also seen those technologies, right? So here is a challenge, right? So suppose every time into a summer you have to apply water. Okay, so you can predict something, right? Depending upon the data, at what point of given time, right? If I switch on the motor to apply the water into the field, right? So that I can get the maximum out of it, right? So I was researching on YouTube. I found really good talk about how the Microsoft is visioning for the using the technology in agriculture farm. Okay, so before that we should think about the challenges, right? Then after we can come up with the solutions, right? So I don't like internet connectivity is a major requirement for any kind of IoT devices, right? As the name suggests, is the Internet of Things, right? So internet is very important, right? So suppose how the entire system looks like. Yeah, so there is a sensors available into the field which can monitor like how much amount of water is there, what is the pH level of that soil. Okay, and then it can give you the a sense of data, okay, into farmer's smartphone, and from the cloud computing you can articulate what are those patterns. But the challenge is there is the farm is very far away from the house, right? So how to get the internet into the farm? So what they did, they used the noise frequency of the TV channels, and which is very cheap, right? So after using it, you can provide the internet. The first thing is we have to take internet to the farms, right? Then second challenge is limited resources, and the available resources are also very expensive. Let's say if you have to monitor a moisture level or a pH level of a soil, right? Then if the farm is like a 1 or 2 kilometer wide, then how much sensor that do we need, right? It's almost around 1,000 sensors, right? And the cost of those sensors are around uh, 80,000 dollars, right? It was a case in New York, right? So if you compare the income of the farmer, okay, with the cost of this system, are somehow not matching it, right? So what they did, they implemented a simple solution. Instead of using that 1,000 sensors, they use only a few sensors, and when they use the drone with the computer imagination, right, and stitching up the entire images, right, they can cover the large area, and also predict what could be from the 10 meters of the sensor that I have placed, right? Suppose there is a 1 kilometer by 1 kilometer farm is there, right? You apply the 10 sensors, and you can rotate a drone over it, okay, and then you can start predicting. It can also, there is some kind of algorithms which can predict the things, right? And also that is developed by ourselves only. Okay, then there was a third challenge. Okay, now we took the internet to the farm, right? We got the sensor which can sense the data out, right? and send it to the farmer's home back, right? Now what we need, it's a very large form of data, right? And we need to take the decisions. Okay, what we need to see, when what's I need the like suggestions. What are the preventive actions that I can take, okay, to solve that problem, right? So what they did, this apply a simple computer system at their home, so they can directly see, because if you see at the Wi-Fi router, we have a maximum speed of 3 Mbps, okay, and amount of data that it is generating, it's like a 1 GB into 10 minutes, right? So if you compare both the things, it's very large data, right? So what they did is they apply a simple computer at the farmer's home, and then all the prediction was happening, all the blue sides that you are seeing was something which is happening at the end of farmer's home. Okay, so if I talk about, suppose this is the example how they had taken the imaginary of the field, and what are the key takeaways that they can give to the farmers, right? Suppose into the morning, right? When at the time where their cows are going out for a eating, right? So here what they articulated, the water puddle, right? So what they did, they took the sensor. The sensors were already there into the farm, and after that they fly the drone for a 30 minutes. So in that 30 minutes, what the key insight that they can give it to the farmer is, there's a water puddle into the middle of the farm, right? The cows are pooping good, so that they can check the cows are okay. Okay, where are their cows? Okay, they are somewhere at a safe place, and there is one cow which is far away from their group. Okay, so directly they have to go and like very quickly they can go and take that cow back, right? So the next is the moisture map, right? So with the help of, now suppose you have a sensors at every place in your farm, right? And then you are taking and predicting something. So let's say if you see on the top right corner, right? It's a yellow area, which is where the highest moisture is available. Okay, and on the left hand side, okay, the lowest moisture is available, right? So what do you need? You have to add the water where it requires, right? As we have very limited resources about it, right? Very limited resource of the water, right? So we just can apply the water when it requires, right? So if you see the two images, right, the difference between two images, once the farmer had applied the water or controlled pH of that soil, okay, so the amount of giving the water to the farm is also got decreased. Okay, so same goes with how much amount of fertilizer is required. Okay, so suppose there is some health issues with the plant, right? Then how and only on that point we can apply the medicines which is required, right? So here I also want to talk about the precisions, right? So suppose you had implemented thousands of sensors in your farm, right? But that is not cost effective. And if you see the other hand of system, right? Yeah, they applied a very limited sensor with a drone kind of technology, right? And that's how it's accurate, right? If you see these blue graphs, okay, which are taken from the with the help of hybrid technology, okay, so it's giving the sense of data, okay, some data that farmer can actually take the decisions on, right? Okay, so at the conclusion, what they concluded is uh, uh, the three most challenges for this program was limited internet connectivity, okay, the power of sensors, okay, not the power or the cost of the sensors, okay, and the deployment of this entire system, okay. And what the takeaway is, we have to create a tools so that we can increase the productivity, we can increase the quality, we can increase the precision into a good crop, right? So yeah, I would like to take give to Mr. Nikhil sir. Thank you.
All right. So, Dr. Preeti, do we have any ways for, I'm going to continue, but if any questions in between, please.
Yes,
either you
Mr.
can-
Nikhil, there are few questions from audience side. So we will take that question. First one is every point of transit and storage, someone has to enter the data, and so how much more input cost will require to have this QR code updated, and will it not unnecessarily increase the unit cost of commodity?
So, basically, I think I tried to answer that question in the chat window also.
But actually, our participant cannot see that. So
Okay. So basically, the question was that if we, one of the example that I mentioned about the apple as a commodity where we wanted to trace the freshness and the originality of the organicness of that fruits, right? So where technologies such as blockchain can be useful. See, the idea is that blockchain is heavily used in a supply chain sector for a long time. And this financial technologies and supply chain, these are some of the good use of it. I'll tell you one real use case that has been deployed by a number of companies where almost $200 billion fake medicines or fake drugs, I mean to say medical drugs, are there in the market. Like we all know it, during the Corona time, remdesivir injections was a big thing. And some of the really greedy people had done some nasty things where they have taken those remdesivir injections, empty bottles, and fill them with the just normal saliva and sodium waters and resold those things. Very unethical. But those issues were there in the market. Now, if we know that at the different points of inter-exchange, we note down the container at the then we know that if I come across some fake medicine, I will be able to trace it back all the way to the origin. Now take the example of fruits, for example, where we're not tagging each and every fruits at the beginning, right? The fruits, see, basically the tag would be only done once. The tag which is as a QR code, that QR code would lead you to the website, which is blockchain enabled. The idea is all the people involved in the whole supply chain, they will be entering their data automatically using mobile applications or like scanners. What happens that fruits been picked up from particular farm in Kashmir, right? Then it has been picked up, there's been assembled into a large container or trucks, right? That all apples are contained into one truck or one batch. They will be given a one tag. So on a supply chain blockchain, you will see that, okay, this piece of apple were picked up from this farm and now it has been these intermediate points. When they alter the supplier, again, the new QR code will be entered at the container level. But when it comes to a retail, at the end, that's where the tags would be entered on all apples, or it could have been entered, or it could have been tagged at the beginning, at the origin. The idea is that QR code would just lead you to one particular website where you can see the entire resume of that particular fruit or particular commodity, right? So you're not adding the costs at intermediate points. That happens at the aggregate level. So that would be my answer.
yes. Another question from the participants is, please share the economics of these systems, maybe IoT devices or anything related to
Sure.
smart farming?
Well, see, it depends on what solutions that you are making. I'll give you one very precise example. A couple of years back, I think, I don't remember exact year, but it was definitely 1 or 2 years before the lockdown. The Gujarat government had a tender. I believe that was perhaps covering some kind of IoT sensor device or some mechanism which would be deployed at every 10 kilometer range or every 10 square kilometer. So tender was about to supply that entire solution, including the hardware for that whole IoT system. It was a couple of hundreds of crore, I believe. So the idea is that many times government has number of schemes that they want to offer. For example, if rain is very poor or very moderate or very low rain, then a lot of farmers might lose their investment they have done for seeds and fertilizers and whatnot. So government, I believe, have a subsidies or some refund scheme that for compensate for those losses, they would give X amount of money back to farmers. But for that, we need to government needs to be mindful about there shouldn't be any mishandling or wrong false claims. So the real beneficiary should be benefited, not the greedy people in the middle. So what was the idea that this sensor mechanism, you can call it as a weather robot for lack of better terms. You deploy that weather robot at every couple of kilometers. So for example, if you have deployed one of them in Anand, another one near Nadiad, another one is in Viramgam, basically at every 10 square kilometer, and that device would be constantly monitoring rain as captured in that particular region. It will capture the humidity, it will capture the temperature, and all this data, including the GPS location, the exact location, latitude and longitude, would be sent through GPS or through mobile network through a server in Gandhinagar, for example, right, at the data center. So whenever somebody or some farmers are claiming for refund, it can be cross-validated that how much was actual rain happened in that particular territory, in that particular locations. Whether, and depends upon that, purely data-driven compensation or refund can be given, right? So that you can eliminate all kind of misclaims or false accounting and whatnot. So in this kind of solution, see the like rain sensor, for example, right, or temperature sensor for a student level projects, it would not cost more than 100, 200, 250 rupees, like. And there could be some combined combo sensor which can measure rain, water and temperature also. However, when you want to deploy into ruggedized in an environmental, in a high temperature, high rain environment, the cost can go higher, but it won't be like in tens of thousands, right? It will be few thousand, for example, that should remain in the field for a couple of years without maintenance. So typically in IoT systems, the cost would involve with a lot of sensors, design, mechanism of assembling all of that, and there are device something called microcontrollers. Those microcontrollers like Raspberry Pi or Arduino boards or Jetsons, there are a number of various boards are available, and there are special custom-made hardware also available off the shelf, and that would cost a couple of thousand, would be easily less than 4,000, 5,000 to 10,000 range. Depends upon what things you buy. You assemble that, and the last component would be the connectivity, right? The connectivity these days is very cheap, right? I mean, when you want to send the temperature data at every 30 minutes, that means in 24 hours, you'll be sending only 48 data points, right? 48 readings basically. And reading is hardly nothing, right? Compared to you take an image of 25 MB, and a lot of people has a habits of going to a vacation, every few minutes they drop the photograph on a WhatsApp or Instagram or Facebook. So even if you send for entire month temperature data would be so less than sending one photograph, right? So communication cost is not that big. And the last cost, which is on the server side, where you will be hosting all this data point aggregation, where data is coming from hundreds and thousands of the location. So you capture that data into server and then you run analytics reports. So I hope this give you perspective, right? That what are the different end-to-end components and architecture involved and cost out of it. The server cost is obviously higher, but that is aggregated, right? One server can handle thousands of IoT devices, for example.
Mm-hmm. Yes. So another question, every expert is, maybe it is question or suggestion, every expert is requested to kindly show some pictures where these systems are used in Indian agriculture, precisely at farmer level.
Okay. Yeah, I can do that. Meanwhile, Kishan, if you want to add anything to previous questions, please.
So is there any device which is very well known to our Indian population, which is used at farming level?
Yeah, it
Any
is
well-known?
popular.
Yeah, I'll try to.
Yeah, please go ahead.
No, I'm going to find some image that I want to show you. Meanwhile, you can talk. And then
Yeah. So,
So-
meanwhile, my question from Mr. Kishan is, you have discussed about one weed robot, right? So, can you emphasize in one or two line how this robot is taking the data and which sensor is actually working for taking the data and what is the format of data?
Okay, so if you see any system, it has a two parts. Okay, if you place into a three blocks, right? First thing is the sensing. Okay, the middle thing is a controlling, and the last thing is the output. Right. So the robot is the outcome of something, right? Something that we had sensed. Suppose if I talk about the example of the soil moisture, the soil available moisture that we are measuring is an example of sensing. Okay, and once we are switching on that motor, right, that's an example of that completing that the loop. That's an output that we want, right? So in context of that's robotics, right? So first we checked the health of the plant and how much amount of pesticide is required, right? And then at the point only where it is required, at that point only we are applying that pesticide.
About that weed robot, I just wanted to know how, if I suppose I develop a device, IoT device, which is basically meant to detect the weed in between the plant, unwanted grass. So, what are the sensor which we are going to use for detecting that weed, first of all, and how that sensor is taking the data, in which format? I actually wanted to know.
Okay, so the weed is something, it depends upon the components that you have, right? If it is just a grass, right, then you can take the computer imagery, right, the high resolution camera, okay, and distinguish between what's a plant and what's a weed, right?
So,
And
camera
then,
sensor is basically working for detecting these things. Is there any
yes,
other
yes,
sensor?
that could be any other sensor, but majoritarily where I had seen they are using camera only. Okay, high resolution camera can also give you the insight. Okay, but at the backing, what we have is called AI and ML, right? So camera can capture the image, and that image can compare with the different kind of scenarios, and then we can or then we can train the algorithm in a way that it can take the decisions whether it is a wanted or unwanted object.
Mhm.
Okay.
Meanwhile, we have another question. Sir,
Can I share the screen
yeah,
quickly?
please.
Yeah. Okay. So see, the question was that can we look at some of those examples of some real, like, devices. So for example, we know that 50% of water is wasted overwatering, largely due to inefficient irrigation methods and system, right? That's some of the statistics. Now, this can be simple system like
Yes.
this, right? It could be as simple as a couple of sensors, which would you feed this kind of device that you see here, that you put it into the soil, and soil would be monitoring the water level and typical few things, which is nitrogen, phosphorus, and potassium. These are the most common things that's required by the soil, and based on that, it will just turn on the mechanism, which will like a drip irrigation, that will just bring the water what is required, right? So that you don't do any unnecessary overplanting. Could be some simple. This is again the POC kind of project, not a commercial product, but you could have some small robot like this that can travel around the field, or images can be taken from a drone. Like, so there is a camera here, or it can be more easily done through a drone, where drone can be programmed to travel the square or whatever the field, the farmer field that they have. It can start traveling from line by row, right? And it can start taking the images of the plants. Now, if any plants developing this kind of diseases, right, that it will be captured by image, and using machine learning, artificial intelligence algorithm, you would be able to pinpoint that this is the area where we can start seeing some kind of fungus is being developed on those plants. So, so that's how it can be done. We can talk more about it in the AI sessions.
Yes. So, Mr. Nikhil, another question from participant side. Sir, please quote the low cost open source free cloud access cloud-based IoT framework, if any, to be exercised on trial basis by the aspirant farmers, agro technocrats to best exploit it. Low-cost cloud-based system.
Okay.
What could be that?
So I think the question is that, is there some packaged low-cost architecture or solution can be made available, which
Low cost open
farmers
source
can experiment?
Yeah.
Open
Source free cloud access, cloud-based IoT, which means the person might be asking, like, if we connect our IoT devices from cloud system to what will be the platform or organization which provide free cloud access, might be his concern.
Okay. So I'll just take a stack at it, and Kishan, you can also chime in. See, it would be difficult to point one particular company, but can be made available, where you can just buy a kit, for example, something for the water, for smart irrigation system. Something could be for this plant disease detection, where you would buy turnkey solutions, where you will get all the sensors and drones and the mobile applications, which all come handy, and then you deploy all that stuff along with the ready-made cloud. That means farmers don't have to obviously worry about deploying the cloud or buying the subscription from AWS and whatnot. It just will be turnkey solutions, which probably we can share with you offline, some of the reference points. But yeah, there are solutions that are available where you can basically do a subscription-based solution that can be available.
Okay.
Yeah. For implementing a prototype of this similar thing, there is a Blink, BLYNK. It's a really good platform where you can use it for prototyping this devices. And
what
also
was that? Sorry for interrupting you. What was that platform?
BLYNK, Blink.
Can you just type on the
Blink? Okay.
There is a Blink. There is a
BLYNK.
Achha.
There
Okay.
is a Arduino IoT cloud.
Yes. And what is the purpose of that Blink?
Okay, so Blink
Cloud
is
system.
yeah, it's a cloud system. So you
Oh,
can actually configure your sensor or your output
yeah.
device, and you can
So
actually monitor it live.
so how much access they will provide to the customer? I mean, how much free access a person can get from there?
So everything is given by the tokens. Okay, they will, once you make the account, they will provide you with some tokens. Okay, and after that you have to purchase it for adding the more devices. Okay, but the Arduino one is quite like you can connect a much number of sensors with that.
Yes, but about cloud system, actually, I am also struggling in this area. Uh, if someone wants to make his or her device, IoT device, completely automatic, not completely, I can say free of human intervention, then they might need this cloud-based system to access the data and to fully take control of that particular device. So subscribing this cloud-based platform, how much data we will, how much access we can get, which is free of cost.
Okay, so it's all free of cost. So if you
Up
see
to
the system, right, the Arduino one is free of cost. You see. Okay, but there is no customization, right? It will allow you into the form that they are using. Okay, if you go into the customization, right, because as us, we can't understand what's the sensor is giving me a data, like it is in form of the values from 0 to 200, or 0 to the 1000. Okay, but what does that value means in actual world, right? We want that thing, right? Water is less, or either we need to provide a water, okay, or a pesticide, right? So for that you need to go into the customization of
So let me just add to that what Kishan said, right? So there are number of complementary cloud-based solutions available, which would let you feed the data from the sensor, and then from mobile application, you would have simple dashboard like this, right? Where you can check what was the temperature, what is the humidity, so and so forth. And this was developed by one of my nephew. He is in 12th grade. So it's not superly complicated. Of course, you have to have motivation. You can figure that out. But for commercial deployment, for reliability and stuff, obviously the game is a little bit different, where you need a lot more robust and foolproof mechanism. But if, let's say, hypothetically, let's say a couple of students at agriculture university want to start with these concepts and play around with it and start to build some simple prototypes, that can be done with, I would say, total investment would be even less than 1,000 or 1,500 to 2,000 rupees to come up with the small prototypes, which would do specific things, right? So we can talk about it offline. If there is interest, we can help you to work on some of those prototype development.
Yeah, thank you. Thank you very much, Mr. Nikhil and Mr. Kishan. You have, explained these whole session very much in an interactive way, and it is informative to our participant also. And we are having your session tomorrow also on, I think, AI and deep learning. If I'm sure about,
Correct.
yeah, AI and deep learning, right? So yeah, we will look forward for your future association, or anyway, whether it is cloud expertise or IoT expertise or AI expertise. So thank you for now, Mr. Nikhil.
Will do. Great. And let me just take a last minute to just
Yeah,
summarize some of the key points.
sure.
That, see, we looked at whole spectrum of IoT and cloud, and Kishan has gone through a number of scenarios and case studies. So if I have to summarize the main objective behind it, I think technologies like IoTs and cloud are very emerging, and particularly, as I said, in agriculture sector, they are not heavily leveraged, perhaps for lack of understanding or knowledge. So webinars like this, I highly congratulate you team to put up these programs together. I think that would open up a lot of ideas and thoughts. So it definitely have a potential to improve the farmers' productivity. It definitely help them to get better ROI and better yield with limited resources they have. So basically exploit the resources to the fullest to get the better returns. It can help you to help them to prevent or the crop failure, basically early disease detection. That's a very important. If you can identify things ahead of the time, right, then you have a lot more control and control your damage and losses. And most important, in my opinion, would be there is a way to develop predictable income and business growth where you are less and less dependent on natural phenomena like water and flood and other stuff, where you can based on your historical data, you can do more prediction that last year we grow this much. If this year we put this much of additional fund, this is what we can expect. So there is a predictability can bring on the business. And obviously health and maintenance of the livestock, which is also very important aspects of the horticulture. So I would say these are the key benefits can be enabled in a very systematic manner. All right. So once again, thank you for the opportunity, and yeah, would love to interact further. Over to you, Dr. Preeti.
Thank you, Mr. Nikhil. We are going to start our next session, dear participants, and we will see Mr. Nikhil's lecture tomorrow in the first and second session, I think. So
Sure.
yes, for now, thank you so much,
Thank you.
Mr. Kishan and Mr. Nikhil. So yes, dear participants, we are waiting for our next speaker. Just give me 2 minutes. He will be joining us in some time, few moments. So just wait for that. Be patient with us.
Okay. Bye. Bye for now.
Yeah. So dear participants, our speaker has joined this Zoom session, and we will going to start this soon. So good morning, Dr. Sharad.
Yeah, good morning.
Yeah, Dr. Sharad, Dr. R.S. Pundir, who is principal investigator of this particular project, he is also in the room. So Pundir sir, would you like to say something? Dr. Sharad is actually founder of Josh AI solution, and he is in the middle of making one robot which is related to agriculture sector, from harvesting up to from sowing up to harvesting. So would you like to say something to Mr. Sharad, Dr. Sharad?
I think Dr. Preeti.
Yes, sir.
Yes, I think the speaker is there, Dr. Sharad Chandra. Dr. Sharad, welcome to this lecture series. It's very, very important. We are looking curiously towards you to listen you and to understand many things. This is very, very important area for all of us. But I think we have a few questions later we will discuss once your lecture is over, probably. Some we would also like to know what our students and others are expecting. But we have high, from your lectures, we are looking very curiously, sir. So yes, this is all Preeti from our side. Welcome you, sir. Yeah.
Yes.
Yeah, thank you very much, and good morning, everyone. Just wanted to check the time available. Accordingly, I can plan my presentation, and maybe we can have some time for question answer session as well. So
yes, we may.
So
Yes,
just wanted
normally at the end
So your timing is from 11:35 right now up to 1 o'clock, and we will be having Q&A. For that, we will keep 10 minutes for QA session. So let me introduce you first. For that, I will call Harshit to introduce Dr. Sharad first. Harshit, over to you.
Hi, yes. Welcome you, sir, Dr. Sharad, sir. And Sharad sir is an agriculture entrepreneur and founder of Josh Artificial Intelligence and Solutions. By profession, he is electronics and software engineer with a PhD in IoT. His main expertise is in crop mechanization for developing advanced robotic solutions. He has more than 30 years of experience in engineering softwares and embedded systems, mechatronics product designs, and development in industrial automation, medical electronics, and semiconductor domains for global customers. Sir has also a very good experience in connected devices, IoT gateways, device management platforms, edge computing, data analytics, and data engineering includes asset management, preventive and predictive maintenance, artificial intelligence, and machine learning for developing solutions for medical, industrial, aerospace, and agriculture domain. The main focus is on improving productivity and profitability of farmers through robotic automation. Sir has also have more than 5 years of overseas working experience in USA and Japan. With huge respect, I would warmly welcome you, sir.
Yeah, thanks, Harshit, for your kind words. And let me share my screen. And possibly it's a combination of presentation and some videos also, so that we can understand the weed management better. And also it will make I don't want to make you bore with a 1 hour presentation for sure. So we'll have a videos also of various equipment used for weed management. So let me start.
Yes, please.
Okay, just wanted to check if you are able to see my screen.
Yes,
and in case if my presentation is not visible, video is not visible, then I request someone from team to tell me upfront.
Yes, sir. We will
So
inform you regarding the visibility as well as audibility also. So
yeah.
right now we can see your PPT.
Okay. Okay, very good. So let me start. The topic today is smart weed management system, and I'm going to discuss this with reference to our robo, Josh Integrated Agriculture Robo, which is a product of Josh AI Solutions Private Limited. It's a 15 months old company, and I am the founder CEO of this company. And our goal is to improve productivity and profitability of Indian farmers by leveraging artificial intelligence. So we are actually, the robo is a combination of multiple technologies like advanced robotics, then computer vision, edge computing, as well as artificial intelligence and machine learning. What is our vision or mission? I think from the very first slide, you'll understand that we want to make our Indian farmers happy and avoid a stressful condition, and ensure Atmanirbhar Gaon and Atmanirbhar Bharat. That's our vision. And these three gentlemen, S.C. Kohli, Kurian Varghese, and Sharad Doshi, these three gentlemen are our inspiration and a role model for building this integrated agriculture robo. First time in world. So we have some patents also filed for this robo, and definitely we are trying to follow the path of this gentleman's for benefit of Indian farmers. So that's our always a mission. Okay. So why we started? I think you must have seen my background. I am a electronics engineer by profession. I have been working with most of the times overseas customer. This is my first product, first project for India. So what was the reason? Because many people ask me why you change your career and why you got into this. So I visited some cotton fields in Akola. I visited one of my relatives there, and then I found that it's a pathetic situation in Akola, Amravati. That's called as a cotton belt of India, and I could see the cotton farms. There is a lot of impact of weed, a lot of cotton wastage because there are no laborers available. And then I started digging into more, and I found that cotton production in India is the lowest in world. So Turkey is the highest, and we are not yet 30% of Turkey. And unfortunately, we are less than Pakistan, 521 kg per hectare. So I started thinking why this is happening. More I talk to farmers, more I talk to agriculturists, I found that we have very low profitability as well because of different reasons. And then I started digging into, and I found that there are. Okay. Then I started digging into more, and I found that there are multiple reasons. There are multiple reasons why we have a low productivity and profitability. And then we started getting into more details. Who are companies offering some solutions for this, and we found none except tractors. There is no automation in India. So automation is always limited to tractors. So we thought we should do something and apply our mechatronics experience and use artificial intelligence to make farmers' life easy and less stressful, and of course to achieve a double income. That's the vision of our Prime Minister Narendra Modi ji. So we started getting into more details, and no one from the team is from agriculture background, the technical team, I'll say. So we tried to get collaboration with the Punjab Krishi Vidyapit, then many agriculturists like Dr. Mayan Ray, Suhaswani, and more. And we tried to understand the various milestones in crop cultivation. So it's like started with the plowing, then seed sowing, fertilizer, then weed removal, herbicide spray. The herbicide spray is typically for weed removal. Either it is a manual process or spraying process. Then crop health monitoring for insects and disease management, insecticide spraying, nutrition dispensing, and finally the harvesting. Okay, so these are the. So today's topic, I think we are limiting to weed management. So I'll be talking more on that. But if you have some questions on other part also, maybe we can address at the end. So what are the challenges? I think we talked about availability of labor is a major challenge, and the skills of labor. So if laborers are available, then those are not skilled labors. So definitely they don't deliver to the expectations. Crop diseases, insects, pests, a major challenge. Harvesting becomes a challenge, mainly for crops like cotton or even for vegetables and fruits. And the crop productivity is adversely affected by weeds. diseases, insects. So these are the major challenges we have seen for farmers. You people being from agriculture university, I'm sure you must be knowing much about this. So then today's topic, weed management. So first let us see what is weed. I will not get into much technical definitions and but weed is a unwanted plant which grows with the crop and competes with the crop for water, fertilizer, light and space. That's a simple definition of weed. So it is basically enemy of the plant, current crop, I'll say. Current crop. So if you're growing soybean and if you have a remains of earlier crop, let it be cotton or peanuts or anything, so that also becomes a weed for current crop. So because it competes with the crop for water, fertilizers, light and space. We started getting into the data because always we believe in data and we can address any problem once we have a proper data with us. So we got some data from some agriculture institutes, like what are the losses of various crops, like yield losses, production losses. So we got some data, like in terms of percentage. You can see cotton is having the highest yield loss, 40 to 60%. And even if you see in terms of money, billions of dollars are wasted because of weights. And it is said that the annual loss in India is of $11 billion every year, and which is equivalent to agriculture budget of Indian government. So it's a huge money, and our goal is to save this money by using right techniques of weed management. We call it the smart management, and that is what we're going to discuss. So before we get into how we can do the weed management, let us see what are the impacts of weeds, because weeds are the main enemies of crop. I think it results into less crop production because it competes with the crop. It consumes a lot of water and fertilizer and nutrition, and it is said that it can result into, we have seen earlier that it can result into 40 to 70% of reduction in crop production. It also impacts the quality of crop because the weeds are always poisonous. So it will weed will take a lot of nutrition which is meant for crop. So the quality of the crop is reduced. Then to address weeds, usually people use herbicide. So it will kill the weeds, but then it will have a impact on quality of the crop. So that's another problem. Weeds, it is a hub of insects and pests. So it provides the ecosystem. It provides the ecosystem for growing insects and pests, and naturally it will impact the crop. Weeds are also food sources of animals, so which these animals will come to crops, and they will also spoil the crop. The animals are also reservoirs for pests and diseases. So again, major impact on crops. Then it will reduce the soil quality. The crop cultivation, it becomes unusable for crop cultivation over a period of time, and naturally the value of land is reduced. It will also interfere the crop management, because if you want to do the management of crop for various insects and nutrition, fertilizer, but then the weeds are grown in between, anywhere in between two rows, in between two plants, and everywhere. So it will definitely have a negative impact on crop management. And of course, it requires more laborers to remove the weeds. It will also cause a discomfort for labor, because if there are weeds in a crop, definitely it is going to cause some poisoning to itching, poisoning, allergies to the labor. And so these are the various impacts. So weed is a main enemy of any crop. And so that's the reason it requires intelligent weed management. And there are multiple methods, like first is the cultural. So you can see different methods: cultural, chemical, mechanical, biological, and so on, how the weed management can be done. So the cultural method is definitely based on the cultivation process of a crop. So what should be the distance between two plants? What should be distance between two row spacing? When you should do the planting? When you should dispense the fertilizer? And so on. So that's a cultural way. It is very difficult to define for particular crop. There are a lot of research going on to prevent that. And also it results into some biological intelligent weed management, like use of some insects, friend insects we call, to avoid weed. But so far it's not so effective. Prevention is also a way of weed management. Like before you start seed sowing, you ensure that there is no weed, control the weed before it. Then using some equipments, you can remove the weeds before seed sowing. And then of course, you should prevent the weed than curing it. Prevention is always better. And of course, the scope of robotics is limited to two methods. One is a mechanical weed management. We'll use some mechanical tools, which we are going to see now. And then you can uproot the weeds also using some power weeder, and possibly still people are using manual labor for removing the weeds. So that's how it can be done. Then use of chemicals, although not so popular in India, as per all the chemical companies, pharma companies, they always say that India is not using herbicide. That's the reason you have a lot of challenge of weed. So use of herbicide, many companies are trying to promote. They have built some application, mobile phone application. You must have heard about Plantex application. So they, if you send a photo of your weed or plant, and then they will suggest you what kind of chemical to be used. But that's more a promotional activity than a prevention activity. And so typically, robo can be used for mechanical and chemical operation. And we'll see how these two activities, weed management activities, are used across India for weed management. I think any questions, or you want to take question answers at the end? I'm okay for that. I believe you are able to, the pace is also okay for the presentation.
Yes, Dr. Sharad, participants have their question. Would you like to take in the middle of session or the end of that session?
I think we'll take it at the end, so that most of the questions could be answered, I believe, during the presentation.
Yeah.
Okay.
So you can proceed with your presentation. We will take those questions at the end of your session.
Okay, and the pace is also okay, correct?
Yeah.
The speed is also fine. Correct?
Yes, perfectly fine.
Okay, so we will see how the weed management tools are evolving over a period of time. I think the easiest way, what we have seen is use of labors for removing the weeds, and then there are some mechanical tools like harrow, then rotary hoe, and power weeder, and inter-row cultivators, and so on. So different tools are now are available for different crops. and few can be used for all kind of crops, or few are specific to particular crop, because the distance between two rows, of course, not same for every crop. So definitely you need to customize those crops. So I'm going to show you one video about mechanical manual weeding process, and then we'll see what are the different tools available also. I'm going to play video. If you are not able to hear the audio or see the video, just let me know. Otherwise, we'll continue. So this is a manual process of removing weeds in between two rows. I think those people who are from agriculture background, they must have seen that, and it's a very simple way of using weed management tool. This is something a very big equipment, and sort of beginning of the robotics. So you can see it can remove the weeds for more than 16 rows, and it basically cuts the weed wherever it is available. It's a mechanical tool. So it is like it is going to chop the weed so that the seed sowing, it is used typically before seed sowing. This is a tool possibly used in Europe and America, where they have a big fields like this. Of course, you will not see such a big fields in India. In most of the places, so this is how it works. This is the parking position. Okay, so now let us go to. Okay, then I think so. This is the first generation weed management manual or using a small tools. Now there are a lot of a lot of mechanization of weed management you can see, but still in India I don't think we have such kind of tools available. Or still it is a manual process, or maybe people are using power tiller. So these are the some big tools, equipments used for weed removal. I have given some examples, and we have some videos also for these tools, which I'm going to show you. So it is manual come automated. It is basically removing the weed close to the plant, close to the floor. This is a fantastic weed management tool. A lot of intelligence you can see here. So it is trying to remove the weeds in between two plants. This is typically a semi autonomous robot, and it's a first, we can say it's a first generation of weed management robot, which is trying to address 2 to 4 hectares per season. It uses artificial intelligence and machine learning for weed management for weeds in between the rows also. Okay, so let us go back to our presentation. So I think we have seen that there are multiple mechanization tools available, and so you can say this is the first generation, this is the second generation, and now the third generation, possibly use of spraying spraying machines connected to the tractor, so they call as the implements. In India, you will find they have converted the motorcycles into mini tractors. They call as a Doshi, and they use the spraying guns for spraying the herbicides on crops. We have also seen drones being used for spraying the chemicals. I think recently Indian government they have started sponsoring a drone purchase by agriculture degree holders. So they're giving some subsidy and from funds, 5 lakh rupees funds for buying drones or spraying the herbicide or spraying the insecticide. Of course, we are not in favor of drone. That's a different topic. I'm sure over a period of time, people will understand why drone is not suitable for such application. In fact, why drone is hazardous for such application. But as we are discussing technology, I just wanted to show you what are the different ways of weed management by spraying the herbicide, a manual process, then spray machines connected to tractors, and spraying using a drone. So maybe we'll see some videos for herbicide spraying also. So this is typical spraying machine connected to a small tractor, and you can see how much chemical is getting wasted because it is spraying on the entire crop, and while it is killing the herbicide, it is also having a impact. They claim that the crops will not have the impact, but it's difficult to believe. So this is some they call it the Desi Jugaad. They have converted the motorcycle for spraying the herbicide, and I have seen this in many cotton fields also, But again, the same challenge, lot of chemical required because it is spraying on entire the crop. It is hazardous to environment, soil, as well as hazardous to the person driving the motorcycle. We have heard about poisoning cases of farmers dying because of such spraying. So definitely there is a need for some solution, and this is drone now becoming hot topic today because it can save some labors. It can spray even on hills. It can carry 20 liters of chemicals in one go. So it is seen as a one-stop solution for spraying the chemicals, but it has got some now you can see it is flying almost 1 meter above or 1 or 2 meters above, because for controlling drone you also require some flying above the crops. So it is creating a layer of 1 meter chemicals above the crop, and because of wind this can get into the villages and will be very hazardous for health of farmers. So we are not very keen, and of course it will require almost 5 to 10 times chemical, and it will not reach to the entire plant. It can reach only on the top of the crop, but it will not reach at the bottom. And we have seen that it may be useful for weed management, but it may not be useful for pest control or insect control, because most of the pests and insects you will find below the leaves of the crop. So it won't be that much effective as it is seen. But so it is. We are just trying to wait and watch how people are reacting to that. Now going back to the presentation, I think now the main topic possibly is weed management using robotics. So over a period of time, like last 3-4 years, weed management using robo is becoming a very attractive proposition for different reasons. First thing is use of artificial intelligence and availability of very high speed computing GPUs, differently automating weed management. And the first company which build this weed management robo is a Blue River. It's an American company, and they have a tagline, see and spray. So it uses computer vision and artificial intelligence to identify the weed. So it will differentiate between weed and the crop. They also develop it for cotton, because again cotton is a cash crop. And so it uses computer vision and artificial intelligence for identifying the weed, and then it will spray the herbicide in a very small quantity. It is projected that it will require only 10% of herbicide. So if you are spending today 100 liters of herbicide, possibly you would need only 10 liters of herbicide if you use this robo. If you use drone, I'm sure you will require 250 to 300 liters, so that you get the desired effectiveness of herbicide. So this is going to save a lot of herbicide. It will also preserve the environment. It will also preserve the soil. It will reduce the impact on farmers' health. And this company has taken, they launched this product. Of course, still it is in a pilot phase. In 2018, it's an American-based company, and it has been now acquired by John Deere, a tractor company, for $300 million, almost 2,000 crore plus rupees. And actually, this news was the main reason why we thought of building the robo. And then after doing a lot of study, we felt that the entire cultivation requires automation. So that's the reason our Josh robo can do seed sowing, weed management, crop health monitoring, as well as harvesting of cotton, fruits, and vegetables, and other crops also. But then there is a company called as Deep Field. Again, it was acquired by Bosch from Germany. So they also have a similar kind of robo. I'm going to show you some videos of this. Then there is a Eco Robotics. They use a Delta robo from Switzerland. Actually, it was built by Eco Robotics in coordination with the university. In most of the countries, USA or Europe, they have very strong relationship with academia and industry to build such niche technology products. We are trying to do that in India. We are so far tied up with two institutes, and we are looking for some more partners also, because it's a huge work. There's a lot of opportunity for building the robotics for different crops in India. We always believe, like, if you know our mission, it is tractorless India in next 15 years. That is our vision, because we always believe that tractor is like a automatic bullock drinking the diesel, and it is rarely used in cultivation, just for 2 months. For seed sowing and plowing, whereas it cannot be used for other operation, because our crops are very dense and tractor cannot enter. As we see in USA, they can use tractors, but in India, it's very difficult to use tractors after the crop grows. Okay. Then we have some. So this is also a Ripa Robo from Australia, again built by the university. FarmWise is a US-based company incubated at Stanford University. So most of the things are getting developed in collaboration with academic institutes. So I think this would be a very interesting video. And last video on weed management. So it has got different weed management robo, and the main theme is see and spray. So it is going to use computer vision, artificial intelligence for identification of weed or differentiating weed from the other crop, the main crop, and then spraying the herbicide wherever the weed is seen. So it's a 3 minutes video, but very interesting. So it is using artificial intelligence to identify the weed. You can see that.
Cost savings on top of everything. We saw an opportunity to take cameras, computers, and artificial intelligence to allow ag machines to see, adjust, and correctly set that machine's performance for the field. One knob could be the protection of the cotton plant and how big of a buffer, a safe zone that we provide the plant, so that when you apply selective materials or non-selective materials, that we have the appropriate buffer. Another dial is how aggressive do you want to be at going after anything that looks like a weed. There's also some opportunities to inform the grower of how many weeds the system's seeing. swarm.
This is deep field acquired by a Bosch company from Germany.
Differentiates between crop plants and competing weeds as reliably as humans do. While driving along the sugar beet roads, plants are analyzed in real time, enabled by precise camera technology and machine learning. And intelligent software distinguishes crop plants from weeds and gives the correct signal for weed removal. Engineers used artificial intelligence to create this ability previously mastered by humans only.
This is Robotics from Switzerland. So they use a Delta robo.
This might be how they would in the future. It's a lot like a 3D printer. It can go anywhere in 3D space. And so that's how we kind of reach down and either we spray or we cut, depending on what we want to do. This robot drives along a field like a tractor. The camera looks at the ground and analyzes the plants. Using artificial intelligence, it decides which are good plants and which are the weeds, even if both are green. Do you know that crops are planted in a row?
Okay, now we have been talking like we use artificial intelligence for weed management. Artificial intelligence is used for weed management. Okay, so what are the different weed removal techniques we have? So if there are basically weeds you will find at 3 different locations. From this 50, you can see there are 3 different locations where weeds are found. So weeds which are available between 2 rows. You can see this is the crop, and there are 2 rows, and in between if you find the weed, so typically this weed is removed by using a mechanical tool. Okay, so you don't use artificial intelligence for this. You just use a rotavator or any cultivator to remove the weed in between 2 rows. Very easy. Then the weeds which you will find in between the crops, like so weed which are very close to the plant, so those would be 10%, and then there would be some weeds between 2 plants but not so close. Okay, so the weeds which are slightly away from plants, maybe they can be uprooted using a gripper. So I'm talking about how the robo applies the logic. So if the weed is very between the 2 plants but very away from the plant, then you can use the gripper to uproot it so that the plant is not affected, the plant roots are not affected. But then there would be weeds which are close to the plant. So then you cannot uproot the weed because that may damage the roots of the plant. So there you need to use spray the herbicide. So here, so for the 10% of the weeds, typically the robo will use herbicide. Rest of the places, either it will use a mechanical tool or it will use a gripper to uproot the weed. So that is these are the 3 methods, techniques used for weed removal. Okay, now the main challenge, how artificial intelligence can be used for weed management, because we have seen that artificial intelligence is becoming a hot topic. Now everyone talks about AI, ML, lot of courses are going on. So what is artificial? Very simple definition. The ability of machine to simulate human intelligence. So that you can define the AI in a simple words. Okay, I don't want to make the things complicated. And again, I'm using the word to simulate human intelligence. It cannot replace human intelligence. It is impossible, because when I was a student in 1990, that time I heard about this artificial intelligence, and now after 30 plus years, now I'm seeing some applications of artificial intelligence when we have a very good computing power in terms of GPU. It will take another 20-25 years to replace human intelligence once we have a higher computing power. So still it is a simulation of human intelligence. So how this will be used? So typically, if you remember, when is a child, we teach the child by showing the things. So the child will show some colors to the child, yellow color, red color, black color, and the child will start remembering those colors, and then will start correlating with various shades of the colors. The exactly same way we teach the computer. We feed the different weed images, we feed different plant images to tell the AIML model that this is a weed and this is a plant, this is a cotton plant, this is a soybean plant, and so on. And then using that data, like we learn from the childhood, the AIML models will start remembering the things. They will remember the features of different images, and then it will start differentiating between plant and weed, and then it will take action on the weed without impacting the plant. So that is how the AI is used for weed management. It will first differentiate between plant and weed, then it will understand the position of the weed, so whether it is close to plant or whether it is away from the plant. Then it will spray the required quantity of herbicide on the weed which is very close to the plant, because we cannot uproot the weed which is close to the plant, otherwise it may damage the plant itself. And then whenever robo finds the weed is slightly away from the plant, then it will uproot the weed using a gripper without affecting the plant roots. So these are the techniques used by the robo. So I'm trying to make it generic. Okay, these are the techniques used by all kind of robots, even the Josh robo also. And then it will use the weed images, plant images to learn the features of weeds, learn the features of plant. It will use some camera sensors to understand the position of the weed, and using this data, it will take the action for weed removal. Okay, so why we should use robo for weed removal? So that is the question always I have been asked. Because a robo can work without dependency on labors, and it can remove the weeds of hundreds of hectares every year. So that is the first advantage of using robo for weed management. It can work without a break for 12 to 14 hours, and you can use a floodlights if you want to use it during the night time. And the cameras what we use, they can work during the night time also using a floodlight. So they can work without any supervision. It will reduce the use of herbicide, so it will not affect the farmer's health also. It will preserve the environment and soil, and I'm sure it will reduce the use by 80%. So there was a lot of saving. Since you are saving the herbicide cost, labor cost, it will reduce the cultivation cost, and naturally the profitability of the farmer will increase to reduce the stress on a farmer. Our robo is 100% developed in India and manufactured in India. We always assure the return of investment in 1 year, and it is not like the farmers, they need to buy this robo. They can also use our unique business model like cotton cultivation as a service, where FPOs and FPOs, they can buy the robos from us and they can rent the robo to small and marginal farmers on a daily basis without a long-term commitment. So that these are the advantages of using robo for weed management. So these are the different parts. I will not get into more details because I know the audience is more from the agriculture background. If you have any specific question, I can answer. But it requires some robotic hands. So either it could be a Delta robo or robotic arm, or you can use Cartesian robo or different type of robotic arms you can use. It requires high resolution camera. We are using Intel RealSense camera. Then you require a gripper to uproot it. You require a spraying tank and spraying nozzle to spray the chemicals. And of course, you require high edge computing devices with AI capabilities. So these are the major parts of robo. And this is a typical structure. It is not the photo of our robo, but it's a typical structure how the weed management robo will move in a crop. Like it will have a mechanical weed removal for weeds in between two rows. You can see that here. Then it will have a robotic arm, robotic structure to remove remove the weeds either by using a gripper or by spraying the herbicide. And then we have seen the advantages of this robo earlier. And this is not a real picture. Okay, this is just to show you how it may look like. Our robo is slightly different than that, which we don't display during public presentations. We want to maintain the confidentiality. But then it is similar to this. Like it will have a wheels, it will have a camera, it will have a robotic arm to spray the herbicide, and it will have a gripper to remove the weed very away from the plant, and it will have a mechanical tool to remove the weed in between the rows. Okay, so that is what we have. I think I'm done with my presentation. If someone is interested to know more, you can reach me out. If someone wants to contribute to this mission, you are most welcome. We'll see how we can collaborate. So now I'm open for question and answer.
Yes, thank you very much, Dr. Sharad. It was actually very much insightful address, and also you are explaining each and everything. How can someone think of weed removal activities from the robotics? So thank you for that. So let me take some questions from the audience side.
Sure.
Yeah. So first is we have land size in less than 1 acre. So these machines will be useful for small and marginal farmers. How these machines will be useful might be his question.
Yeah, means I think I mentioned that if someone is a small farmer, marginal farmer, you don't have to buy this robo. See the size wise, it can be used because it doesn't require a tractor. I think I forgot to mention that our robo, it doesn't require a tractor. It's a electric vehicle operated on a battery, and the size of this is smaller than or same as Alto or a nano car, and it's an electric vehicle, so it can get into very small field, and small farmers, they need not buy this. They can rent it either from FPO, or we have a CCAS model. So we are building a network of Josh Agri Army. So these are going to be young agripreneurs in every small villages in India, and they will get this robo through financial institutes, and they will rent this robo on daily basis. Like, you don't have to pay more than 1,000 rupees for renting this robo, and it can do, means, although we discuss about weed management, this robo is an integrated agriculture robo, can do seed sowing, weed management, crop health monitoring, that is the insect and disease management, as well as harvesting. So there is no long-term commitment required, and also this will have a subsidy. We are talking to Government of India, and we will get a subsidy under intelligent cultivation equipment. So small farmers too can also afford very easily.
Okay. Next is sensor available for pH, temperature, dissolved oxygen, ammonia, nitrite, phosphate, alkalinity, salinity level to detect in ponds?
Yes, so this at present we talked about weed management, but this is the IoT enabled robo, and we have built equipment for and interfaces for soil health monitoring also, that will take care of all the measuring parameters you mentioned just now, as well as it has a interface with weather data, also interface with the irrigation system, so that the entire crop management can be achieved by this robot.
Yeah. Next question is, all herbicide contains harmful chemical and very dangerous to environment, is there any organic herbicide or method to remove the weeds?
Okay, so at present we are not offering that because as of now our scope is to reduce the use of herbicide. Yes, people are trying to use electric shock signals for killing the weed, but those are at a very initial stage of development, and it also may have some impact on soil. That someone has to do a lot of research, and so any new technology will take some time to see the positive and negative impact. As of now, we are limited to reducing use of herbicide.
Yes, yes. Next question is, how weed removal can be possible for closely spaced crops? I think that you have already answered.
Yes, I answered. We'll use a herbicide if the crop is if the weed is very close.
So I think I'm done with almost all questions. There are no questions from participant side. Let me check one more time. Yes, I'm done with the question. And so, Dr. Sharad, how can we, decide the possible distance which we consider as a close one for the plant? How much distance we consider in between plant, that is the close one, which will harm our original plant while removing that weeds?
Yeah, it will depend upon the crop. Because if we consider the cotton, then we need to see how the roots are growing below the soil, and accordingly the distance will be calculated. If it is soybean, it will be different. because the distance between even two plants will be different. Distance between two rows would be different. So it is basically based on the crop data. So it is not fixed for the robo. It is programmable, and you need to just enter which crop you are using, and accordingly the distance should be calculated based on the database.
Yes, based on the crop.
We are not measuring the distance.
Yes. One more question I wanted to know, Dr. Sharad. We are building these robots which are larger in size. Can we move towards any robot which is more portable and much better to handle the small and marginal farm size? Is it possible to make some portable robot, or we have to anyway we are compared to make it a large size robot?
Okay, just for a proof of concept or to make something do it yourself, building a small size robo is okay for learning purpose. But if you have to deploy in a field which will have a very harsh environment and very harsh abusive use of any equipment you can find, even the tractors get damaged. So I don't think a very small robo would be a right fit for the harsh environment in a field. You can use a small robo at home for cleaning your floor, but you cannot use that size robo in a field. You know? And then the soil or the field is also not even. So
Correct.
I don't think such a robo can run or walk in a field in India. You need a smooth surface, so that is not the case in field, correct? Sometimes there would be rain, sometimes there would be mud. Yeah, there would be mud. So that is good to showcase something as a hobby.
That will be good for some greenhouse or some glass house.
No, even greenhouse also is not so simple because I have seen that. It is not so simple.
Okay, and what are the challenges of solar operated robot while the change in weather, like in raining situation, how the robots are going to operate, whether there is limitation we have in that case?
Okay, our robo is a solar operated. It's an electric vehicle, works on a battery, and those batteries are charged by using a solar panel mounted on the roof. But of course, when there is a cloudy season, definitely you need to charge those batteries during night time.
Okay. Okay, thank you so much, Dr. Sharad. I also would like to associate with your Josh AI solution, especially for the AI/ML part, and I will contact you after this session also. So, thank you so much for giving your time for this particular lecture. And for further proceeding, I'm handing over to Harshit. Harshit, are you there?
Hi, Asmin.
Yeah, please close the session.
Hi, Asmin. Thank you, sir. Once again, you have really done a very excellent job by giving us knowledge about weed management using robotics and artificial intelligence. And we are looking forward to hear you again speak again. Thank you. And now we'll have a break for the lunch, and we'll meet back soon in this meeting after 2 o'clock. Thank you.
Thank you very much. Have a good day. Bye-bye.
Sir.
Bye.